Okay, the last thing here in section 9.4 is I want to practice learning how to construct sequences given certain terms of sequence and the fact that it's either arithmetic or geometric. So let's start here by looking at if this sequence is arithmetic. So we're just going to make that assumption that it is arithmetic first over here on the left. And it says that the second and the fifth terms of a sequence are 3 and 24 respectively. And so what I want to do first is I want to set up two equations that represent the second and the fifth terms and then set them equal to 3 and 24 respectively. And so if I start with the fifth term, and I always start with the bigger term first, the fifth term is 24. Well, how do I find the fifth term of an arithmetic sequence? I take the first term and I add n minus 1 differences, which in this case would be 4 differences. And so in this case, this particular problem, that is going to equal to 24. Now, for the second term, in order to find the second term, I would take the first term and I would have to add n minus 1 differences. Well, for the second term, n is 2, and 2 minus 1 is 1. And so that's just going to be plus d, and this is going to equal to 24. And so the first step is I always set up two equations. And so I'll just write that up over here to the side, is that I'm going to set up two equations. The second step is that I'm going to subtract those equations. And so when I subtract the equations, that means that a sub 1 is going to cancel out. When I do 4d minus d, I'm going to end up with 3d. And when I do 24 minus 3, I'm going to get 21. And so step 2 is to subtract the two equations. And then I'm going to solve for d. And so when I divide by 3 on both sides, that's going to give me d is equal to 7. And so now that I have my common difference, I can substitute back in to the one of the two previous equations and get my first term. And so step 3, if you will, is to find a sub 1 by plugging back into the original equations. And it won't matter which one you plug into. Either way, you're going to get the same answer. So if I plug into the second equation, just because that one looks a little bit easier, a1 plus d, which is 7, is equal to 3. And so therefore a1 is equal to negative 4. And so now I am ready to write my rules. And so I'm going to start by writing the recursive rule, because that one's a little bit easier to do. And so for the recursive rule, I'm going to have a1 is equal to negative 4, and then a sub n is equal to a sub n minus 1 plus my difference, and that is valid for n greater than or equal to 2. And so here is my recursive formula right here. And now for my explicit formula, I'm going to have a sub n is equal to a sub 1 plus n minus 1 times d. Go ahead and distribute your 7, so negative 4 plus 7n minus 7, and so that ends up giving you 7n minus 11 for your explicit formula. And so this is how I would have worked the problem with the assumption that the sequence is arithmetic. That's why I used these formulas up here, because I was told it was an arithmetic sequence. And so I know the formula for that is a sub 1 plus n minus 1 d. So a sub n is equal to a sub 1 plus n minus 1 times d. That is for an arithmetic sequence. But for a geometric sequence, I know that I have another formula. Let me use a lowercase a. A sub n is equal to a sub 1 times r to the n minus 1. And so I'm going to do pretty much the same similar step here in the second part of this problem, where I assume that the sequence is geometric. It's just that I'm going to use different formulas whenever I set up my equations. And so I'm going to have here a sub 5 is equal to a sub 1 times r to the n minus 1, which is going to be 4, and that's going to equal to 24. And then a sub 2 is going to equal to a sub 1 r to the n minus 1, which is just going to be to the first power, and that's going to equal to 3. And so once again, the first step, just like it was in the first part of this example, is I'm going to set up two equations. But notice I did it differently. I used the geometric formulas here because I'm being led to believe that in part B of this problem that the sequence is geometric. Now, instead of subtracting like we did before, we are going to divide the two equations. And so if I just put division bars here and here, then what's going to happen is that A1 is going to cancel. R to the fourth over R is going to give me R to the third. Let me not use a highlighter here. Let me use a pen. Yeah, here we go. R to the third is equal to 24 divided by 3, which is equal to 8. And now to solve for R, I'm just going to take the cube root of both sides. And so the cube root of 8 is going to give me a ratio of 2. And so now that I have that ratio, I'm going to be able to substitute back into one of the original problems, or one of the original equations, sorry, in order to find a sub 1. And so if you go into the second equation, that one seems a little bit more straightforward. A1 times my ratio of 2 is equal to 3. And so divide both sides by 2 to get A1 is equal to 3 halves. And so now if I'm ready to set up my recursive definition, then that's going to say A sub 1 is equal to 3 halves, and A sub n is equal to 2 times A sub n minus 1, and that's valid for n greater than or equal to 2. And then for my explicit formula, then I'm going to say A sub n is equal to my first term, which is 3 halves, multiplied by my ratio to the n minus 1 power. And so I'm going to work two more examples like this to give you more of a feel for this, but hopefully this is making sense so far. Okay, here on example 9, we're told that we are working with a geometric sequence, and we are given the 4th and the 9th terms, and we want to find the explicit and the recursive formulas for the sequence. So the first thing I'm going to do is I'm going to set up two equations, starting with the 9th term, which I know that for a geometric sequence is going to be A1 times R to the 8th power, because that exponent is n minus 1, and this is going to equal to 196,608. Now for the 4th term, the 4th term of a geometric sequence is going to look like A sub 1 times R to the 3rd power, and this is going to equal to negative 192. Okay, after I set up those equations, because it's a geometric sequence, I'm going to divide. And so when I divide, this is going to give me on the left-hand side, R to the 5th equals to negative 1,024. And so now I'm going to get R by itself by taking the 5th root of both sides. And in the TI-84 calculator, in order to do that, you're going to hit Math 5. And then you're going to have to change the root to be the 5th root in order to find the 5th root of negative 1,024. And what you're going to end up getting is a ratio of negative 4. And so now that I have a ratio of negative 4, I'm able to plug back into one of the original equations and solve for A1. So if I go back into the second equation, and there's not a reason that I'm doing the second equation every time, it's just that usually those numbers are a little smaller, and so that makes things sometimes a little easier. This is going to give me A1 times negative 64 is equal to negative 192, and so divide both sides by negative 64, and you're going to get A sub 1 is equal to positive 3. And so now I'm ready to write my formulas. If I start with the recursive, I'm going to say that A sub 1 is equal to 3, and that A sub n is equal to negative 4, A sub n minus 1, and that's valid for n greater than or equal to 2. And for the explicit formula, that's going to say A sub n is equal to A sub 1 times my ratio of negative 4 raised to the n minus 1 power. Okay, one more example similar to example 8 and 9. We're going to see that the 3rd and the 8th terms of an arithmetic sequence, which means that I'm going to go back to using my arithmetic explicit formula, which I know is A sub n is equal to A1 plus n minus 1 times d. So we want to find an explicit and recursive formula for this sequence, and so I'm going to set up a couple of equations first. A sub 8 I know is going to equal to A sub 1 plus 7 differences, and according to this problem, that's going to equal to negative 3.5. And then the third term is going to equal to the first term plus 2 differences, and that in this problem is going to equal to 14. And so there's my setup, and I know when that I work an arithmetic sequence problem that I'm going to subtract these equations, and so that's going to cause the A sub 1 to cancel out, and then I'm going to get 5D is equal to negative 17.5, and dividing by 5 on both sides is going to give me my common difference of negative 3.5. Now, if I want the first term, I need to plug back into one of the original equations. I'm just going to go into the second one because the numbers are smaller there. So A1 plus 2 times my difference is going to equal to 14. And so this is A1 plus 7 is equal to, minus 7 is equal to 14. And so therefore A1 is equal to 21. And so now I'm ready to write my formulas, my recursive formula. I need to start by giving the first term, which is 21. And then the recursive definition will say an is equal to an minus 1 minus 3.5, and that's going to be valid for n greater than or equal to 2. And then my explicit formula is going to say an is equal to a1 plus n minus 1 times the difference. And so this is going to end up being 21 minus 3.5n plus 3.5. And when I combine the like terms, I'll have negative 3.5n plus 24.5. And so there's my explicit formula for this sequence. And so if you guys have any questions about sequences here in section 9.4, please don't hesitate to reach out, and hope you guys have a good day.